Imagine losing $1 million an hour because, I don't know, a $5 rubber seal broke at 3 a.m. on a Saturday.
Yeah, that is definitely a scenario nobody wants to wake up to.
Right. But in the world of heavy industry, that isn't just some hypothetical nightmare. It's a constant threat.
Absolutely, it's the reality they live in.
So usually when we talk about buying something, you look at the sticker price, you compare it to another sticker price, and you make a decision.
Right, the standard consumer mindset.
Exactly. But today we're looking at how multi-million-dollar operations survive and how that simple sticker price mentality it goes completely out the window when failure is not an option.
It really does. It has to.
So welcome to today's deep dive. We are unpacking a really fascinating, frankly, no-nonsense piece of industrial literature today. It's an excerpt titled 1600H T4F, the industrial standard for relentless air power.
And what's surprising about this spec sheet is that it reads less like an engineering manual and much more like a playbook for a chief financial officer.
Yeah, it really does.
We're using this massive piece of equipment, a heavy-duty Solaire portable air compressor, as our lens to understand the high-stakes, incredibly intense world of heavy industry procurement.
So tense for sure.
We want to decode how massive operations evaluate risk, physical power, and the true hidden costs of getting monumental tasks done.
Right. And I want to say, even if you have absolutely no background in heavy manufacturing or, oil and gas, the concepts we're exploring today are incredibly powerful.
Oh, they apply everywhere.
They really do. It completely dismantles the idea of shopping for the lowest initial cost. We are going to see how unexpected downtime, government emissions regulations, and even global logistics actually dictate the survival of these sprawling operations.
And to understand that financial chess game, we first have to understand the sheer brute force of the machine at the center of this document.
The machine itself is just a beast.
It really is. The text introduces us to the 1600 HT4F portable diesel rotary screw compressor, and the language they use is very deliberate here.
Yeah, they don't mince words.
No, they don't. It explicitly states that in a heavy industrial environment, small compressors are essentially toys.
Toys. Wow.
Right. And they say mid-range units will simply choke when real volume is required.
Which makes sense when you look at the raw numbers provided. I mean, they are staggering. We are talking about 1,600 CF liters.
Yes, cubic feet per minute.
Right, 1,600 cubic feet per minute of flow. For our metric listeners out there, that is 45.3 cubic meters of air being moved every single minute.
Which is a massive volume.
It's huge. And it delivers that at a pressure range, holding steady between 80 and 150 psi, or about 5.5 to 10.3 bar.
And you need serious muscle for that.
Exactly.
Yeah.
To generate that physical force, the compressor relies on a massive 540 horsepower or 403 kilowatt heavy-duty engine.
Because pushing 1,600 cubic feet of air into a compressed state every 60 seconds requires a very specific architecture.
Right.
The document highlights that this is a rotary screw compressor. Now, unlike the small piston compressor you might have in your garage.
The one that just goes chunk, chunk, chunk when you turn it on.
Exactly. That one just uses a cylinder pumping up and down to squeeze air. But a rotary screw design is built for continuous, relentless flow.
How does that actually work inside the machine?
So picture two massive, interlocking helical screws inside a tight chamber. As they spin at incredibly high speeds, air is drawn in at one end.
Okay, I can visualize that.
And because of the shape of the threads, the space between the screws gets smaller and smaller as the air travels down the chamber.
So you're taking a massive room full of air and just physically crushing it down into a tiny, highly pressurized space.
Exactly. Continuously.
Okay.
Without that pulsating stop and go of a piston.
Wow. Okay, to put this in perspective for you, if you've ever used a standard air compressor to fill up a car tire, that's a garden hose.
Good analogy.
Yeah, and what we were talking about with the 1600H T4F is the equivalent of a municipal water main bursting open.
It's a completely different scale.
It is. But looking at these specs, a 540 horsepower engine is what you'd find in a high-end sports car or, a long-haul semi-truck.
Yeah, it's a huge engine.
Okay, let's unpack this. Is a 540 horsepower engine really necessary just to blow air around? I mean, it sounds like overkill.
I get why you'd think that, but what's fascinating here is how the physics apply. Think of engine torque like riding a bicycle up a very steep hill in high gear.
Oh, man. I hate that feeling.
Right. Speed doesn't matter in that moment. If you don't have the raw leg muscle, the torque, the moment the hill gets steep, your legs lock up. You stall out and you fall over.
You just can't push the pedals.
Exactly. And pushing massive volumes of air creates immense physical resistance. The source talks about heady load cycles and peak demand.
Meaning they aren't just running this thing for 5 minutes to blow off some dust.
No, in the field, these systems are taxed to their absolute limits for hours or days on end.
Wow.
So the 540 horsepower guarantees that when the operator opens the valves wide, the engine has the raw torque to keep spinning those heavy screws without bogging down.
The text actually highlights specific field-proven use cases where that raw torque is completely mandatory. And pipeline pigging is a major one.
Oh, that's a perfect example.
Yeah. For those unfamiliar, pipeline pigging involves sending a large physical device, which they call a pig, miles down inside a massive oil or gas pipeline.
Just deep underground.
Exactly, to clean the interior or inspect it for cracks. So you are pushing a heavy, solid object through endless miles of steel pipe using nothing but compressed air.
It's incredible when you think about it.
It is. And if the pressure drops, the pig gets stuck deep underground. That is a multi-million-dollar disaster.
Absolutely. And other applications mentioned include massive blast cleaning operations or emergency dewatering of flooded sites.
Pushing all that water out.
Right. Or providing continuous plant air for essential pneumatic controls. In a massive factory where robotic arms and assembly lines are powered by air, dropping pressure means the entire factory floor just freezes in place.
Which is terrifying for a manager.
Oh, yeah. So you are buying the guarantee that the pressure needle won't drop to zero.
So you have this 540 horsepower beast drinking diesel fuel to keep up that unyielding pressure.
That is not cheap.
No, it's not. And that massive fuel burn and raw power brings us to a CFO's nightmare, really. How on earth do you justify the daily operating cost of a machine this size, let alone a whole fleet of them?
That's the real challenge.
The document advises procurement teams to plan on fleet-level integration, which shifts our focus to the source's core business philosophy, abandoning that simple price per unit idea.
Right, and evaluating the total cost of ownership, or TCO.
Which changes everything.
It really does. The literature tells us that sophisticated managers track 3 highly revealing metrics.
What are they?
Cost per delivered hour, cost per cubic foot of air, and cost per avoided emergency call.
Here's where it gets really interesting. The concept of total cost ownership isn't new, but seeing it applied with life-or-death financial stakes is eye-opening.
It's a completely different level.
Think about buying a printer for a home office, right? You buy a cheap inkjet printer for $50. The sticker price feels like a massive win.
Until you need ink.
Exactly. Then you realize the ink cartridges cost $60 each. They dry out constantly, the paper jams, and you waste hours troubleshooting the thing. That cheap printer is a financial trap.
A classic trap.
But buying an expensive industrial laser printer up front means your cost per printed page over 5 years is just a fraction of the inkjet.
If we connect this to the bigger picture in heavy industry, those ink cartridges and paper jams translate to millions of dollars in lost production.
Millions. Just gone.
Right. And the text points out a really counterintuitive insight regarding fuel consumption here. You would naturally assume a 540 horsepower engine is just a massive fuel hog.
Oh, absolutely. I would assume it just guzzles diesel.
Most people do. However, the document notes that the Solaire air end is perfectly optimized and matched with that heavy-duty diesel package.
Meaning what, exactly?
Well, a smaller engine would have to redline constantly. It would be running at its absolute maximum capacity, burning fuel incredibly inefficiently just to try and keep up with the demand.
Oh, like driving a tiny car on the highway and having to floor the gas pedal the entire time just to keep up with traffic.
Exactly. But the 1600H operates in the sweet spot of its torque curve. Because it isn't struggling, the actual fuel consumed per cubic foot of air delivered drops.
That's wild. So buying a bigger engine actively saves you money on fuel.
It does. And this leads directly into the strategy of fleet complexity, which the document heavily emphasizes.
Right, the consolidation strategy.
Exactly. A major tactic outlined here is replacing multiple smaller compressors, like the widely used 185 series they mention in the text, with a single 1600H unit.
Because using 5 smaller compressors to do the job of one massive compressor creates an absolute logistical nightmare.
A nightmare for everybody involved.
You aren't just paying the sticker price for 5 machines, you're paying to maintain 5 separate diesel engines. You're paying for 5 heavy-duty trucks to transport them to the site.
And 5 different setup routines.
Yes, 5 refueling schedules, and potentially 5 different operators just to monitor them. Consolidating into one machine slashes transport, setup, and labor costs exponentially.
And simplifying the fleet also attacks the most critical variable of all maintenance. The text drops a profound truth for any procurement officer here.
I love this line.
Yeah, it says, gear that's hard to maintain dies in the field.
It's so true.
If a technician has to spend 3 hours taking off metal panels just to reach a simple air filter, that filter won't get changed.
They'll just skip it.
Exactly. But the 1600H T4F is engineered for immediate service access, utilizing modular replacement parts and extended service intervals.
And the predictability of that maintenance schedule is just gold.
It's what keeps them running.
A proven air end and simplified access translate directly to higher uptime. It means you can forecast your aftermarket spend accurately. You aren't guessing when a machine will break down, you're scheduling routine swaps.
And that predictability is what a CFO is actually buying.
But maximizing uptime and consolidating your hardware is only part of the equation, right? Safely deploying a 540 horsepower machine into highly regulated environments requires navigating an absolute labyrinth of government safety protocols.
The environmental laws alone are staggering.
You cannot just buy the machine.
Right.
You have to buy an ecosystem of compliance. The document places massive emphasis on the compressor being Tier 4 final emissions compliant.
Which is a huge deal in this industry.
Yeah. For those outside the heavy machinery world, Tier 4 final represents the strictest environmental regulations for off-highway diesel engines implemented by the EPA.
And it is not easy to meet those standards.
No, it requires engines to drastically reduce particulate matter, which is essentially black soot and nitrogen oxides.
Achieving that compliance mechanically is incredibly complex. It usually involves advanced exhaust after-treatment systems.
Like what?
Well, the exhaust is treated with diesel exhaust fluid, or DEF, in a process called selective catalytic reduction.
Okay, science class.
Yeah, the system literally burns off the harmful particulate matter before it can even exit the exhaust stack.
Wow. And while that is clearly an environmental necessity, the text frames it as a critical operational safeguard too. The document states this compliance keeps regulators and environmental teams from breathing down your neck.
Because if they show up, you're in trouble.
Exactly. If you try to save money up front by purchasing an older, cheaper, non-compliant compressor, an environmental inspector can walk onto your site, flag the exhaust, and shut your entire multi-million-dollar operation down on the spot.
Just halt everything. And the structural design of the machine serves a similar risk mitigation purpose too. The literature highlights the heavy-duty chassis, secure canopies, and engineering for stable towing and secure lifting.
Because when you are lifting a multi-ton piece of equipment with a crane on a crowded job site, an unbalanced load is a lethal hazard.
It's terrifying.
Fast, secure lifting points mean fewer delays dealing with workplace safety regulators like OSHA. If a rig doesn't have certified lifting bales, the site manager has to wait for special permits, or they have to call in specialized rigging teams.
And time is money.
Right. Waiting for an inspector to approve a sketchy lift is just burning capital.
And to manage this complex web of hardware, compliance, and global logistics, the source introduces the necessity of a strategic partner. They point specifically to pneumatic.com.
Right. The vendor.
The literature argues that while purchasing a 1600H is possible through dozens of vendors, managing multiple sites and bulk maintenance requires a partner that converts hardware into what they term operational leverage.
pneumatic.com is positioned as an entity that provides wholesale pricing for bulk orders to reduce unit cost, and custom financing to preserve a company's capital. But most importantly, single-source accountability.
Yes, that is key.
The document actually includes a buying checklist, specifically an RFQ, or request for quote checklist. They advise buyers to demand guaranteed spare parts distribution, specific warranties, and emergency response SLAs.
Which are service-level agreements detailing guaranteed response times like a 4-hour window.
Right. So the RFQ checklist forces the buyer to look past the physical steel of the compressor and really evaluate the strength of the safety net surrounding it.
Exactly.
But wait, this raises a flag for me. The document pushes heavily for a single-source vendor. One purchase order, one support number, one vendor to manage key performance indicators or KPIs. Isn't that an incredibly risky move?
How so?
Well, if you put all your operational trust under PE Energy and they drop the ball on parts distribution, your whole site goes dark. You are putting all your eggs in one highly pressurized basket.
This raises an important question, actually. We are typically taught to diversify risk, right? So relying on one vendor does seem counterintuitive at first.
Yeah, it feels like a bad idea.
But consider the reality of a crisis in heavy industry. Remember that 3.0 AM broken seal scenario you brought up earlier?
Oh, the $1,000,000 an hour
Yep.
nightmare. Yes.
Exactly. If your plant is losing thousands of dollars a minute because a specific bracket failed on your compressor and you've diversified your vendors, you are now managing multiple points of friction.
Oh, I see where this is going.
Right. You're calling the manufacturer to check the warranty status. You're calling a separate local distributor to see if they have the bracket in a warehouse.
Right.
And then you're calling a third-party service company to find a technician awake at 3 a.m.
Yeah.
to drive out and install it.
You are trying to coordinate a rescue mission with 3 different entities who have absolutely no obligation to talk to each other, all while the clock is ticking and the financial losses are just compounding.
It's chaos. Having single source accountability means you have one legally binding contract that includes a strict emergency response SLA and guaranteed spare parts distribution.
You just make one phone call.
One call. The burden of coordination shifts entirely to the vendor. The text explicitly mentions needing guaranteed availability so your plants don't drop to zero because of a bracket or seal.
Right.
In a high-stakes crisis, having one single point of contact, one throat to choke, so to speak, is vastly safer than piecing together a fragmented response network.
That makes a lot of sense. The text turns a simple purchase order into a performance guarantee.
It really does.
The vendor is tasked with modeling fuel, service, and downtime scenarios upfront, becoming a true partner in risk management rather than a simple supplier.
And that transition from evaluating the cost of acquisition to deeply evaluating the cost of operation and the cost of failure, that is the hallmark of sophisticated decision-making.
Bringing this all back to you, listening to this deep dive right now.
Yep.
Whether you are managing a multi-million-dollar construction fleet, preparing for a tense business negotiation, or even just organizing your department's annual budget, the mental models inside this industrial document are surprisingly applicable.
They translate so well.
The framework of total cost of ownership, the strategic advantage of system consolidation, and the realization that predictability is often worth a premium up front. These are strategies you can deploy literally anywhere.
We've journeyed from the raw physics of 1,600 cubic feet per minute of brute force through the mechanical complexities of Tier 4 final emissions after treatment right into the high-stakes chess game of RFQ checklists.
It's been quite the ride.
It has. We've explored how a massive 540 horsepower engine isn't a luxury. It's an active defense against the crushing resistance of heavy load cycles.
And we've seen how consolidating a fleet slashes invisible logistical costs, right?
Yeah.
And how true operational leverage comes from building an ironclad ecosystem of guaranteed parts and response times around your most vulnerable assets.
Because the most profound takeaway here is that in any complex system, the highest cost isn't the price of premium equipment.
What is it?
The highest cost is the catastrophic failure of cheap equipment.
Wow. So what does this all mean? Think about the invisible infrastructure powering our modern world right at this very moment.
It's all around us.
It is. The next time you drive past a massive highway construction site or a sprawling manufacturing plant, or you see the markers for an underground pipeline, consider what is actually holding the entire operation together. The most critical asset keeping that complex web of activity from collapsing isn't the steel beams or the concrete or the massive trucks.
No, it's not.
Deep in the heart of that site, the lifeblood of the operation is a precisely engineered, relentlessly sustained stream of highly pressurized air. It really begs the question, how much of our modern, highly advanced civilization literally relies on the hidden high-stakes business of just making sure we never stop moving air from one place to another?